Welcome back.
Hi everybody. We're going to start with some graphing.
We have a sine function that looks like this. We're going to pick 5 very important points out of this function. I don't know if you remember earlier in the year we did transformations of graphs, all of our parent functions.
Yes.
Sine and cosine were one of them, but all we had to do was match them. We never graphed anything with them.
Well, we're back, and so we're going to do a whole lot with sine and cosine now.
Our 5 major points are going to be 0, 0.
I like 0, 0.
Pi over 2, comma 1.
Okay.
Pi 0. 3 pi over 2, negative 1.
Hey, these sound like quadrantal angles.
2 pi 0. They are. And if you did the exploration, those 5 numbers are on your chart. But lucky for you, you don't have to plot all those numbers in the charts from the exploration. You only have to worry about the 5 numbers.
And if you did the exploration, you'll understand why sine looks like a roller coaster and not shark teeth. So
yes, it's very nice and curvy.
Very nice.
All right.
All right, what about cosine?
Cosine looks very similar, but we're going to start at 0, 1. Then pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. And 2 pi, 1. And again, these points come directly from the unit circle. We're just putting them now on graph paper.
Okay.
Plotting them.
So for both of these functions, the input, the x value is what?
A radian angle.
A radian angle. And the output are the values from the unit circle.
They're just the ratio of those sides of a triangle or whatever else you wanted to memorize from the chart.
So we're used to cosine being x, but now the x coordinate of that dot is going to be the y part of the graph.
True.
Okay. All right, some terminology we need.
All right, what is a periodic function? Well, it's pretty much just a function that repeats itself. It's any function where the y values repeat. So both sine and cosine are periodic functions. They have this wave shape to them. No, we're looking really strange here right about now. Okay.
That's not a first for me.
All right. Period is the time or the number of units it takes to complete one cycle or one before it starts to repeat itself. That's a cycle. So go back to our pictures real quick.
Absolutely.
Those 5 points for our cosine were one cycle, but you see on the other side of the y-axis, those 5 points repeat themselves, and you get the same picture
So how long
over and over again.
So how long does it take for this value, which is going down from the x-axis, to go through one whole cycle and be right at the x-axis again going down?
Well, for this function, that takes about 2 pi.
It does. It's easier to count if you start from the origin, the y-axis, and go across, and it goes
2 pi. Now that's not a coincidence. That's actually the length of time it took us to take one trip around the unit circle. Was 2 pi. One trip around the unit circle will repeat sine, and one trip around the unit circle will repeat cosine.
All right, what's this amplitude stuff?
Amplitude is how high something is, but it's going to be half the distance from the highest to the lowest point, all right? So if you have your sine function right here,
There you go.
amplitude is going to, well, it goes up to 1 and it goes down to negative 1 in terms of its highest point
Correct.
and its lowest point. So how far apart are those two numbers?
So that's 2 units.
2 units, and half of that distance is
1 unit.
1. And we're going to basically view it as from that midline, that middle area right there. In this case, it's the x-axis. And pretty much everything today is going to be on the x-axis.
Yes, everything.
The amplitude will just be how high above the x-axis the graph will go. Now, as we move these things left and right and up and down, the concept of amplitude will have to be viewed as the distance between the, or half the distance between the highest and the lowest points.
Exactly. Remember that amplitude is a distance, so you will never have a negative amplitude. You always have a positive amplitude. There's one more application to amplitude. You know what
would
it
that
is?
be?
You can talk like this. Or you can talk like this! That's what amplitude is.
If you heard the first part.
If you heard the first part.
Okay, now, what are we going to do with these things?
You get to do some graphing. Here you go.
I get to do some graphing.
Okay, have fun.
Awesome. Okay, so first things first. We're going to graph this function here, y equals 2 sine of x. And I'm going to start with my parent function and my transformation rules that we learned way back at the very beginning of the year. Okay, so first thing I'm going to do is take my sine function, and remember, we had 5 points that we wanted to use for one period. Now you can graph more of them, they just repeat themselves, but we're going to have a minimum of those 5 points. Your job is to remember where they are. So what I'm going to do first is I'm just going to graph those 5 points so you can see how this differs from the parent function. So I'm going to go all the way to 2 pi. That was my period.
Correct.
Then I'm going to break it in half.
That's 1 pi.
And half of 2 is 1. Then I'm going to break each half in half again.
Okay, that's pi over 2.
This is pi over 2. Now, the problem people have is finding that third line. How do you suppose we're going to do that?
Well, these are quarters, so can I just go pi over 2, pi over 2?
Yep. This is just a number line, so this is 1 pi over 2. This would be 2 pi over 2, and this would be
3 pi over 2.
3 of them. Just count. It's not that bad. And our 5 points were going to be 0, 0, pi 0, 2 pi 0, and the board seems to be having a seizure. Pi over 2, 1, 3 pi over 2, negative 1, and our parent function looked like this.
Yes, so what does that 2 do?
Okay, is this 2 inside or outside of my sine function?
It is outside.
Outside, because the only thing inside would be messing with the x. So outside messes with what variable?
Y, the vertical direction.
Vertical direction messes with y, so it makes the y values twice as tall.
Correct.
Well, anything on the x-axis twice as tall means there's still 0.
Yes.
So it takes these points of 1, pi over 2, 1, it makes it twice as tall, so it stretches them vertically to 2.
Okay.
And then it takes the point negative 1, or 3 pi negative 1, and makes it twice as far from the x-axis, which means it's at negative 2.
So it's just twice as tall.
Twice as tall, stretched
Okay.
away from the x-axis, twice as tall. But your 3 points that were on the x-axis are still there, and there's our sine function. Now, it doesn't just stop there. It keeps going on both sides, and it would repeat with the same pattern.
Forever, because the domain is all real numbers.
Forever and ever and ever and ever.
Okay, so the domain is all real numbers.
Yes.
Okay.
Now, we managed to do y equals 2 sine of x. So what did the 2 change from my parent function?
Well, it made it twice as tall.
And what do we call that tall part of this?
Oh, that's from the middle up. That's amplitude.
Amplitude. So this 2 happened to be the amplitude, or the height from that middle line of the x-axis to the highest point, or, again, half the distance between the highest point and the lowest point.
Okay, so the amplitude is 2.
The amplitude was 2.
Got it.
All right, fair enough. Let's do y equals cosine of 2x. We'll start off again with our parent function. Cosine had a period of 2 pi, and then it was going to go to pi, and then we broke those in half, and it was going to be pi over 2 and 3 pi over 2. And we were going to go from 1 to negative 1.
But this time cosine starts at 1.
Cosine starts at 1,
Yep.
ends at 1, halfway hits negative 1, and then 0 at the halfway between the other two, and goes like this.
And usually people forget the 0
Yeah.
when they graph.
Don't do that.
The reason we're chopping this into quarters is because every time you go past a quarter, you should be making a dot.
There's like 90, 180, 270, 360. Every quarter of that unit circle, we had a point.
Right.
So here we go. Cosine of 2x. Well, I've got a 2. Is it inside or outside my function?
Inside.
Inside, so does it mess with x or y?
That's x. That's horizontal.
So we always do the opposite to x's than what we're doing in the problem. So
Right. So
we
that's
are
half as wide.
half as wide. We are taking the distance that it took to get from here all the way to here, and we're making it half as wide.
Oh, wait a minute. Wasn't that period?
That
to
is the
complete one
period.
cycle? Okay.
We're going to talk about that more in a minute. So instead of waiting till I got to 2 pi to get to my new point, how long is it going to take because stretching this point or shrinking it doesn't change it.
Correct. So it means I need to end in half the distance. I need to end at pi.
That point's going to end up over here now because it's only going to be half this distance.
Right.
And everything else is going to shrink to half.
So don't I need some halvesies on my x-axis?
We'll get there.
Okay.
Let's go with pi. Pi was at negative 1, and then it's going to be shrunk to pi over 2 negative 1.
Right.
But then I've got to shrink this point. It was at pi over 2, and I got to go halfway, right?
Pi over 4?
That's pi over 4. So I'm going to actually move that point over. Whoop, can't move that. Well, we'll just draw the dot. That point's in the way. All right. But now I'm counting by pi over 4, so I got to cut all of these in half. Is that okay?
Okay, yeah, because we want the same scale.
So that's 1/4, 2/4, 3/4, 4/4, 5/4, and
Okay.
so on. The only point I haven't cut in half yet is right here. If I cut that in half, well, you could count it. You go 1, 2, 3, 4, 5. It's 6 spaces from the y-axis.
It's going to be 3 spaces.
So now it's only going to be 1, 2, 3 spaces, and we've got our function. Okay? Now, it will repeat itself, but does that look like it's half as wide?
Yes.
Okay, now,
So the period was pi.
the
Is
period was
there
pi.
an easier way to figure that out?
There's going to be a much easier way to do this, okay?
Okay.
That was a little messy. Hopefully, you noticed that. All right?
A lot messy.
We actually want to do the next two by finding the amplitude and finding the period before we start, and then we can create our scale. Because as you can see, trying to graph that parent function and then shift everything creates a really big mess on our axis, doesn't it?
Yeah, that's kind of a messy.
It's really ugly. Now, you're welcome to do it that way, but you're going to have to be a lot neater than we are, which may not be that hard. But
Speak for yourself.
all right, she's the neater one of the two.
Okay,
All right.
so tell me an easier way to get to period.
All right, so let's talk about period here. If you noticed, our original period was what?
2 pi.
2 pi. And that number that was in front of our x value, we basically divided by that number because we do the opposite when we're inside.
Right.
So it turned into a shrink. So our period in this problem was the original period, 2 pi divided by 2, or that's where that 2 came from.
Okay.
So in general, what we have here is if y is equal to cosine of bx, or even if y is equal to sine of bx,
So if there's some number there.
some number in front of x multiplied by x,
Okay.
the period is simply going to be 2 pi divided by b.
Okay.
Instead
So
of multiplying, we're going to divide. So if b was a fraction,
copy dot flip.
we multiply by the reciprocal. How's that?
That's a fancy way.
I know. I can't handle this copy dot flip thing.
All right, I think I got it. Let me try some.
Okay, you try it.
Okay, here we go. You're going to help me, right?
I'm going to help you.
Okay, so we've got y equals negative. Oh, you give me the hard one.
You
Of
picked them.
cosine of x over 2. Okay, well, I know that there's not anything being multiplied in front, so my amplitude should still be 1 because it's a distance. So what does this negative outside mean?
Well, when the negative was outside, we got the opposite y values. So that means we reflected it over the x-axis.
Yes, we did. So this is going to flip over x. Okay, we'll deal with that in a minute. All right, just a minute ago you said period was 2 pi over b. I see x divided by 2. That tells me my b is a half. So my period is 2 pi divided by that half.
Which is the same as multiplying by 2.
Correct. So my period is actually stretching to be a 4 pi. Now what Mr. Lucky was trying to tell you is you don't have to graph the parent function to begin with. Now that we know we have to get to 4 pi, we can start off by making our scale based on 4 pi. Our first mark goes at 4 pi because that's where we're going to end. So then we chop that in half. Half of 4 pi
2 pi.
is 2 pi. Chop that in half again.
We get 1 pi.
Okay, so that means that each of these little units is counting by pi. We got 1 pi, 2 pi,
How about 3 pi?
3 pi. Is it chocolate? 4 pi. Okay?
Do we do this every time?
We do this every time. Chop it in half again.
And then just use that to count to 3 of them?
Use that and count to 3 of them. Okay, the amplitude is 1. I agree. Still 1. Okay, and this is a cosine. So where are we going to start for cosine?
We started at positive 1 for a cosine graph, but this thing gets flipped
did.
over the x-axis.
Okay, so I'm going to put my dots on here first.
So this would be the cosine of x over 2 without the negative?
Yes, this is the cosine without flipping it. And then we just need to flip it over the x-axis. So this one that was up here at 1 is now going to be, that didn't work for me.
You have to put the marker down.
It's going to be there. What if I flip something on the x-axis?
It just stays where it's at.
It stays where it's at. What if I flip this one, which was at negative 1? And
Now it's at positive 1.
That's kind of fun when you put the marker down. Okay. And this last one was at 4.
Except for now you can drag both of them.
Am I?
Go ahead.
I don't know what it's doing. I'll just draw it because smartboard, blah. Technology. And remember, it's not shark teeth.
It's a nice smooth curve
It's a nice smooth curve. Okay?
that keeps
Alright.
going forever.
And ever and ever.
So all we really did was change the scale then. We
Correct.
basically we flipped it over
Yes.
and went from 0 to 4 pi instead of 0 to 2 pi.
Yes.
That
That's
doesn't
it.
sound too hard.
It's not hard at all. Let's look at letter D. We're going to do both a amplitude change and a period
So
change.
the number in front of the cosine or sine function changes the amplitude
Correct. And it's the absolute value of that
every time?
every time.
Wow.
So the amplitude is 1/3. The height of this wave would be
1/3.
1/3. The period,
The period's going to be 2 pi divided by the b value, but
which was 1/4,
b is a fourth.
that's 8 pi. Again, it still works with our rules about the stretching and shrinking. And you can do it that way. The reason we're showing you this period is 2 pi over b is because of the next example that's coming. Okay? So you want to get that in your brain.
So do we just mark off 8 pi,
8 pi, because that's our period.
and then take half,
Half of that,
then take half again,
half again is 2 pi.
and then just count by 2s?
Count by 2s, 2, 4, 6.
That's too easy.
Super easy. This is a 1/3. This is a negative 1/3.
You mean I don't have to go up to 1?
Nope.
I can just label it 1/3?
As long as you label, that's the big part. You can't just put some tick marks on a piece of paper because then we won't know what you're talking about. We're going to assume they're ones and you'll get it all wrong. This is a sine curve. It starts at 0, then it goes up, and then it goes back. You can't cross the axis without putting a dot there. And 1, 2, 3, 4, 5. So it goes smooth continuous like a roller coaster.
Yahoo!
I play the roller coaster song in my class.
Do you?
Yeah.